Well, welcome to the, let me see, August 16th, 2022 session of TangerineSDR and Hamside Technical Session. My name is Dave, KV0S, and this week, I haven't done too much on the project, although I have cleaned up my my magnetometer. It seems to be providing the correct number of values per day. I'm using Joule's recommended parameters. So my only glitch was just a day after I changed the parameters, I had a power outage, so that didn't give me a full day. So, and I didn't have a battery backup at the time. I now have a battery backup on it. So that's, you learn by experience. Anyway, that's it for me. Next on the list is Nathaniel, W2NAF. Go ahead, Nathaniel.
Thanks a lot, Dave. Yeah, things are going fine here. It's been very busy. I'm in Indiana, Pennsylvania, visiting Rachel's parents for a couple of days. I think we're heading back to Scranton tomorrow. I've been, running around trying to work on a number of papers and things. So my student Francis and I, we just did a little contribution to this paper for a software data analysis toolkit for
SuperDarn
called PyDarn. So we're working on that. And then I'm working with Christina on some grape data visualization code, which I'm hoping that code base. I'm going to talk to Hyomin a little bit more about that, and also with Jonathan Rizzo. I'm hoping we can use that code base to also incorporate some visualization tools for the magnetometer and VLF data, because I think it'd be really useful to be able to visualize all of that data all in one toolkit, because really we want to see how these different things relate to each other. I'm also working on this survey, this white paper for the National Academy of Sciences Decadal Survey. And so they're basically asking all of the scientists in the space physics community to write white papers talking about what they think is important. And I'm supposed to write a white paper about how amateur radio is important to the space physics community. And we're also supposed to provide some recommendations. So maybe during the open session, if people have some ideas on what I might recommend or might include in the paper, I'd be happy to hear them. I can tell you what I'm thinking so far. I've been working with Jonathan Rizzo and to try to work with Morris Cohn at Georgia Tech to get some more funding for the VLF side of the system. And I'm working with Hyomin and Jules and Dave Witten to start working on a magnetometer paper. So I haven't been doing a whole lot, but I'm trying to keep going. So,
very good.
Back to Nat.
Next on the list is Dave, KD0EAG. Go ahead, Dave.
Not a lot of excitement this week, I don't think. Can't remember precisely where I was last week, but I doubt I'm much further. I think I've been fooling with fiber optic stuff mostly. But that's about all there's to say. Back to you.
Okay. Thank you very much. Next on the list is David N1 HAC. Go ahead, David.
Good evening to the net. Yeah, the decadal survey sounds like a really interesting project, and it's, I think, co-chaired by one of our own, Robin Millen, who I've done a lot of work for with the balloons. Let's see. I've been, trying to get noise studies done on our Antarctic power system. Currently waiting for wind is the problem, but we'll see where we can get on that one and moving ahead on that. Baffin Island is giving us some data. One station is giving data. The other station, we're not quite sure what's going on. And unfortunately, we don't have South Pole running right now. And of course, that's all done. We're working remote with the technician down there, trying to bring our system back online. But just to remind people of what that project is, we've got 2 stations at conjugate points of the Earth's magnetic field. So that we hopefully will see things bouncing back and forth between the 2 sites. And then a new little project is, I understand that there are 2 new E-Loran sites on the air, Nevada and Washington. And while they're a bit far away from here, should be able to at least see the Nevada one. So I'm powering up my Loran receivers again. Maybe even be able to get some timing information off of it. See, which is, of course, its point is that it's intended to be a robust replacement or complement to GPS. So busy over here. Back to net.
Well, fine business. Next on the list is Don, K1VX. Go ahead, Don.
Let me get unmuted here.
There you go.
I'm the newbie here. I actually hadn't heard about this project or this program or this organization till a few days ago. And it caught my interest. I'm a retired communications engineer. I spent 22 glorious years working on land mobile radios at Motorola, and about 25 years working on different aspects of cellular communications. So a lot of broadband stuff, CDMA, TDMA, OFDM. And most recently, spent the last couple of years of my career working on space communications with a defense contractor. Retired about 4 years ago, moved here to scenic East Tennessee. We're about 20 miles south of Knoxville. And
Yeah.
actually had an interesting part-time gig last year with another defense contractor working on, to some extent, HF propagation, which I thought was kind of interesting. I'd never worked on HF anything in my life outside of ham radio. But anyway, I been looking over some of the documents on tangerines and grapes and things like that. I'm not sure they're the latest. Some from the dates look like they might be a couple or 3 years old. So maybe they're up to date, maybe not. But kind of feeling my way around to see if there's something I can contribute. Maybe I build up a grape. Maybe I start looking at some other aspect of what you guys are doing here. So that's my story, and I'm sticking with it.
Well, welcome. And yes, unfortunately, most of those documents are relatively up to date. COVID got in the way, and then supply issues got in the way. And so some of the parts have been redesigned to work with available parts. But that's about where we are. And welcome, and I'm sure you can find something of interest to work on in our project. So, very good. Whoop, still muted.
Okay, I pushed it one too many times. There we go. Yeah, okay. So I'm just going to kind of nose around and see what you guys are up to and see if anything jumps out at me. And keep looking at some of the documents. I was planning to jump on to the grape meeting, assuming they have one this week on Thursday.
Yeah.
See what's going on there.
Also be aware that next month in Charlotte, we're going to have the DCC, the Tapper DCC, and that will have a lot of ham site talks.
Okay, well, Charlotte's not too far down the road from here, so.
Yep.
Might be-
That's what I was thinking. Okay, next on the list is Hillman. I can't remember your call
I
sign.
forgot to put that.
Go ahead, no,
yep.
Hillman.
Yep. Good evening, everyone. So yeah, I've been on and off, especially this summer. I've been traveling a lot. Been to BBSO, Owens Valley Radio Observatory in California, and test meeting last week was held in Seattle, Bellevue, which is near Seattle. I just realized that that's the place where Bill Gates and Joe, what's the Amazon guy?
Bezos?
Bezos
Yeah.
are leaving. So
Yeah.
our hotel was very close to where they live. So anyway, that doesn't really mean anything to me, but I realized that the place was pretty fancy, a lot of like new hotels and new apartments, pretty clean, fancy. Yeah, there was the citizen science talks. There are a lot of citizen science talks. There was actually one specific session that was actually organized by my colleague at NJIT that actually drew a lot of attention from people. NSF representative were there, and she really liked my talk. And Liz McDonald from NASA, who is also very doing a lot of citizen science, really liked my talk too. So we actually sat down together to discuss our just like Nathaniel mentioned, we talked about the decadal survey white paper discussion, which was very helpful. So I'm into it. Yeah, and then other than that, I'm working with David for our Antarctic project, which is, occupying me a lot. So other than that, there's not so much going on. Back to the net. Thank you.
Oh, okay. And next on the list, let's see, James, KG4 DSG. Go ahead, James.
Good evening, Dave and the group. Not much going on here. I've been spending a couple of days trying to locate some light bulbs for some load testing on a UPS. And incandescent bulbs are getting almost impossible to find. I finally found one that's a 300 watt single bulb, and it's under $5. So I have a feeling I'm going to be picking a couple of those up in the very near future. But other than that, everything's wattage equivalent, and that doesn't do it for me. I need the actual wattage. So
I'll give you a hint. The 3-ways are available.
well, I was actually looking at this bulb in a 3-way to give me a slight adjustment on the high end. We go
Yeah,
from
50,
300.
100, 150s are available, I noticed.
Yeah, they'll go from, well, this bulb will be 300 and a 3-way would take it to 450, which is right where I want it. It's a sweet spot on this UPS. And I have a feeling that the testing is going to reveal that all the batteries are dead. So it's really kind of a fool's errand at this point, but it needs to be done. So with that, back to the net.
Well, good luck with that. And next on the list is Jim, K4 BSE. Go ahead, Jim. Oh, Jim, microphone.
Sorry.
Good.
Good evening, everyone. I have not been doing much on ham radio and might be doing even less the next several days. My wife got back this afternoon from a music convention that she went to in Chicago, feeling pretty puny. She gave herself a home COVID test, and guess what she has?
Oh,
So where she's isolating in another bedroom right now, and we'll have to see what things are like. And I talked to one of my daughters just before this net, and she pointed out that, well, you drove home with mom. You were in the closed car with her for about 45 minutes. You better take a test too.
yeah.
Anyway, not a whole lot of what I've been doing is not ham radio or ham site related, so I won't bore you with it tonight. Back to net K4BSE.
Okay. Next on the list is Joe, W7LUX. Go ahead, Joe. Joe, you there? Well, he must have stepped away or something. Let's go on to Jonathan, EY. Go ahead, Jonathan.
Hi, everybody. I haven't really been doing much this past week because I've been busy packing because I'll be moving. So I really didn't have much time to work on a lot of stuff. But I was working with Nathaniel to kind of expand the VLF portion of this project, which I think will work really nicely. So I'm really excited about that. I'm also I didn't have time to, but I intend to get Python notebooks running on my FreeBSD system. I had them running when I took Nathaniel's DSP class back in the fall of 2020, and I just forget how to get them running now. So I will figure that out. The intention is to try to import VLF transmitter amplitude and phase data into the Grape 1 multiplot notebook to correlate GOES X-ray data and Grape amplitude and Doppler shift data with VLF amplitude and phase data. So what you'll see is the reduction in amplitude on the Grape data will correspond to an increase in amplitude on the VLF data, and that will the Doppler shift on the VLF data will correspond to the change in phase on the VLF data. So I'm excited to kind of correlate SID data with Grape data when there are solar flare events. So I'll be working on that. I'm also working on my presentations for Tapper as well. And I have to get back to the to my H-field receiver and data recording system, as well as my EBNOT rig that I hope to bring to Tapper to actually demo. That's all I have. Back to the net.
Well, thank you, Jonathan. And let's see if Joe is hit there now. He seemed to reboot his computer. He just disappeared again. Next on the list is Mary Lou West. Go ahead, Mary.
Hi there. I do data analysis with Nathaniel on ham-sci radio data. We've been looking at the year 2017, and we're going to correlate that with machine learning techniques and then move on to other years as well.
Very good.
Mary Lou's part of my Tuesday morning group with Bill Engelke and Diego and Gareth. Bill Engelke sends his regrets. They got a storm down in Alabama, a lot of lightning, and apparently blew out their internet. So he said he can't make it tonight.
And if you were involved in the stuff that Bill showed at Hamvention, that was quite interesting. Very good.
Cool.
And Mary Lou is also, she's my physics professor from when I was an undergrad.
Oh,
So she
Very
taught me
good.
everything I know.
So I taught him everything you know. Yeah, right.
yeah. Okay, let's go on. Let's see, we got Jonathan, Tom, oh wait, Jules. Jules,
Yes.
K2KGJ, go
There
ahead.
you go. Okay. Not a lot this week, although part of it was spent replying to Hillman's request for more detail on the hardware design for the paper that's coming up. And I sent through a couple of questions. The main questions I had was, if we're going to do this, do we sort of freeze the design at the level of that is on the local side, at the computer side, freeze it at the level of the Tapper board that we have ready for distribution, and in fact quote that as a component that's available? Or do we need to actually describe that in detail, giving circuit diagrams and so on and so forth? Do we treat it as a component, or do we freeze the design at that point? The reason I ask is I just got a schematic from John Gibbons, which I forwarded to Dave too, about the GRAPE 2 support for the magnetometer. So that'll be for the future, but that's not currently a fully vetted constructed design, whereas the present Magpie hat is, and it can be cited as an available component without, I think, without any further comment other than here's how you interface to it.
Yeah.
We can talk about this more during the open session, but I would lean toward the freezing with what we know we have works. And there's intention of writing a similar Hardware X paper for the GRAPE version 2 when that is done. And at that point, all the details that go into the GRAPE version 2 will go to that paper. But here we know we have this standalone magnetometer project working. I think we just document it as a standalone magnetometer project. Maybe we include a paragraph or a couple of sentences explaining how it is, this project is inspired or, somehow part of this bigger system, but we don't go into those details. We just say the scope of this paper is we're documenting this standalone thing.
Yeah, that was kind of my inclination too. Yeah.
Based
Yeoman?
on what we will be delivering, right? The final product.
Right.
Yeah.
Because this is the thing that works. I'm hoping that one day when the Tangerine is done, when we get more things integrated, I'm hoping we'll eventually be able to write a top level paper that explains the whole personal space weather station system as a whole integrated system.
Right.
But I think along the way, this is like a chapter or a stepping stone, to that goal. And it's also its own standalone thing right now.
Yeah, I mean, as you might know, I didn't really realize how how engineering oriented this paper is. Like, if you look at this, like it is asking like about bill of materials and specs and cost and everything. So I think we need to have all these details based on the final product that we are eventually going to be delivering. So
I think this is good though. I think this is good to have a very engineering focused paper because the grant is to design prototypes of these systems. And so I think having the actual hardware documented from an engineering standpoint makes a lot of sense. And then hopefully we'd write another paper, which Hyomin or one of his students would presumably lead, that looks at some more of the science that comes out of it.
Yeah, we can put in an explanatory note, essentially the basic function of the Pi Mag hat in terms of its isolation characteristics and so on. But as far as anything further than that, in terms of a detailed schematic, we'll leave that out and consider that an available part off the shelf.
Yeah.
Okay.
Okay. Next, we have 2 new people, and I'm going to call on Tom, so he isn't the last one in the list. So Tom, N5EG, sorry.
Okay. Oh, good evening, Dave, and hello to everyone in the group. It was a busy week. I started out by tracing the FPGA pins on the dev kit over through the adapter board and where they'll go to the modules. And after I got a spreadsheet put together, I noticed that Scotty had already done all that work and put the FPGA pins in parentheses on schematics. So I've saved a lot of trouble there. So that was great. Backported the FPGA project to the previous working structure. Both the hardware and the software got all that working. and sent a copy of that, uploaded it to Dropbox, sent a link to Kwong. And I don't know if he was able to build that successfully. I think he probably was. Found the absolute file addressing bug in the Neo software. And it turns out when you copy a directory structure containing an FPGA to a new location, one file, which is an XML file in the software, gets left with the text pointing at the place you copied it from. So when you generate the software, you overwrite the old directory. The one you carefully debugged and archived is a working file while you've completely wiped it out. So whenever you copy a design over, you have to use a text editor and go edit one line in a XML file to point to the new place. So got that done. And I'm trying to now connect the I2C to the pins on the FPGA. And I'm such a total Verilog novice that my head is swimming trying to figure that out. I found the Verilog code for the driver. Basically, the SCI puts out, the data output is actually an output enable to an open drain driver, and the inputs connected to that same output pin. And so I know how to generate the Verilog code. The question is, do I put it in a new file? Where does it go? The instructions say to use the core IO pin utility to do all this. And searching the internet and all the docs found no such animal. So I think maybe they meant the pin planner rather than that. But the pin planner gives you one function and one wire to one pin. And I got two wires to take to it. So I'm a little bit on the newbie side here, trying to figure out how to do the hardware hookup on the FPGA. I know we got some pros on this Zoom call in that area. So back to the group, Scotty.
Okay, next, let's call on Dan. He's got a lower alphabetic name, so Dan.
Okay,
in
thanks,
for
Dave.
XWE.
Thanks, Dave, and good evening, everyone. Can you hear me okay?
Yes.
Okay, thanks. Well, I'm in Arizona right now, trying to stay cool, and we're just getting started on testing stuff. So that's kind of the plan for this coming week is to get everything tested and moving down the chute. So back to you, Dave.
Boy, you look like a champion, Dan.
Why
From
is
what-
that?
your
Oh, yes,
background.
yes. I think that's from Scotty and Nona's cat activities from years
Okay.
ago.
So next on the list is Scotty. Wait, where are you on the list here?
Well, he spelled his name starting with 4 A's.
He's
so
hiding
gotta be
from you.
pretty near the top.
Oh, okay, you're
Aardvark.
Aardvark. Okay.
You said you were going to call them in alphabetic order. So I think,
Well, but I moved you down because we haven't heard from you for a while. So I figured you're going to talk longer than anybody else.
oh no, I'm probably going to take a nap here.
Okay.
As you
So
can
go
see
ahead,
over here-
Scotty.
As you can see over here on the left, I don't know if you can see in the background here.
Mhm.
That's 23 IQ2 boxes that we're building for Zephyr. So pretty much the end of the line for IQ2s because that's all the parts we have. So anyway, I still got blisters on my finger from bolting the boards down. Anyway, as Dan said, the next up we're going to do adapter boards and
Magnetometers.
boards. Yeah, I forget, And let's see what else. Probably could help Tom out on a few things if we can do that in the general session. I guess we don't really have much more except let's see, who was it here that was it Jim that had a grant from ARDC in his club? And so Jim, you're here, right?
Yeah, you talking to me?
Yeah, did you get an ARDC grant?
The club did. I actually talked to the two requesters at the last club meeting, and they're interested in providing information to me.
So can you give us a little talk about it?
Define little.
15 minutes?
Be stretching it, but I could probably do it.
Well, we could give you a little less time if you don't feel like filling 15 minutes, but you're going to DCC, right?
I'm planning on it, yes.
Okay, because
and I did talk to the two, I guess you call them PIs in this case. They are willing to discuss it with me before I leave for DCC, but
they're
we
not
haven't
going,
done
right?
that yet.
They're not going to be there in person.
They're not going, no.
Okay. But anyway, so I'll send you an invite and copy John Hayes because he's going to be kind of the moderator for the Sunday session.
Okay.
On the Sunday session, we want to go through and have a whole bunch of very short. We applied for a grant because why, and what we did with the money, and how hard was it, how easy was it, et cetera, to show kind of the diversity of grants that they're giving out. So that's and you know, you can make it technical. That's good because this will be a technical audience. So you want to talk about you know, technical details of what you use the money for or why you need it, that would be great. And if you want to give something on Saturday, I mean, a technical presentation, the Sunday is going to be more of a grant focused, and Saturday is going to be more of a technical focus. So you get to pick whichever you want.
Okay.
So anyway, I'll drop you a.
I just sent you my email.
Oh, okay. All right. Perfect. Did it? That didn't come out, did it? Oh, yeah, there it did. Okay. Thanks. Perfect.
Okay.
Anyway, that's all I have. Back to you, Dave.
Okay. Well, I think I called on everybody, even the aardvark.
Even the aardvark. I don't know what
So-
noise an aardvark makes, so I'll refrain.
Okay. So I assume we're open for general discussion.
Can I open the discussion again with Kyomin, Dave, and Jules about the magnetometer paper for a minute?
Sure.
Yeah, so I for the part where we said we're going to just include the Raspberry Pi hat as an off-the-shelf component, but that's the part that Scotty designed, right?
Yes.
Mhm.
Why
That's
would
what-
we? What's that?
Go ahead. Sorry.
Why would we not include the schematics from that?
Well, we could, but do we have to include a bill of materials?
Is there-
Shortly, you'll be able to order them from Tapper.
Well, okay, so the idea behind this Hardware X paper is that I think the Hardware X journal wants to have a bill of materials and they want open source hardware designs. So I think they would like to see that.
Scotty may have something to say about that.
I could generate a bill of materials from the ORCAD and just include
Do you
that
consider it open source?
and consider it. Yeah, I guess we can. I'm a little reluctant to give them the Gerbers because you should buy a board from us if you want to do that, and it's going to be cheaper to buy it from us than to make your own. But-
I don't think the Hardware X, I don't think they required the Gerbers. I think they wanted a schematic and a bill of materials.
Okay, so I think we can do that. And we give them a PDF of each, and then they can do whatever they like with it. And the main thing that I think that you get out of the open source is you are able to look at it, see what we did, see the techniques that we used, and then build your new gizmo based upon that. I mean, that's kind of what I did with Dave's, with your schematic. I mean, I just took that piece and I looked at it and I said, okay, I started there, and then I add and subtract and move things around and come up with my own. And that's what they would do.
Yeah.
But they would be ahead because they started with something they know worked. And that's not what I know. We know Dave's worked. So that was a big bonus that we connected up like that. It's going to work. So is that, and we can do a bomb. I think that's no problem.
Let me show you what the template for the paper is.
Yeah, so I'm looking at the template right now. They are actually requiring CAD files, 3D printing file, electronics, PCB layout, software and firmware files and stuff. So I don't know if they are mandated to share all these or.
I mean, if this isn't going to work, we could consider, publishing into a different journal.
Well, it says the PCB layouts and other electronics design files can be uploaded as supplementary materials. So it does not look like they're required.
Yeah.
That's what it says down there under the third line, electronics.
Yeah, I think as long as we show that nothing is proprietary, that's fine, I think.
It's,
We don't,
it's actually the schematic is marked as released under Tapper OHL.
Mhm.
So
And
it's
you're
right on the
actually-
schematic page.
Yeah, you're obligated, all designs must be submitted under an open source license.
Right. Which means use it any way you want. It's, here you
It
go.
has to Be a
Right.
legitimate, has to be an accepted open source license.
Which I
Okay.
think they actually specifically say the Tapper open source license is a.
I'm not sure whether that,
But
I'm
it-
not sure whether that's considered, whether that is considered open enough.
It
Oh,
said something about.
It actually, I think it specifically mentions that one.
I
It
don't
said
know.
something about them needing to be editable.
There's several different questions here.
Open hardware licenses for the equipment. See, they actually specifically,
Yeah,
Okay,
that's the one we're using. So
yeah.
So the point being is that they don't want to prevent commercial use. And so that's what we don't do.
well, it's more specific than that.
Well, the Tapper in that particular category, that the Tapper OHL doesn't prohibit commercial use.
No, but you usually attach an addenda to that, protecting yourself for a certain period of time or
Right,
something,
right.
don't you? Yeah, well, that's not open.
Well, okay, but in this case, we're not really doing that. We're not attaching the addenda. So
You're gonna have to
that
say
was-
that, you're gonna have to say that clearly.
well, okay, this is, but if I identify the Tapper OHL as the license we use on the schematic, and then you go to the Tapper site and you look up OHL and you read it, it doesn't say anything about prohibiting use for some period of time. So I think that's something that, like for HPSDR, we did that as a separate kind of understanding between the community and us. And I don't really think we need to do that this time around.
I think from
never been
the
discussed.
grant perspective, I think we should do this because the NSF grant specifically says that we're designing this under open, stuff. So I think if we released it in a paper like this, I think it would be very well received by the NSF.
You're gonna have to do that with the other components as well.
Yeah.
And the people who track these things care very much about the letter of the law on how these things are followed.
Mhm.
Okay, now, David, maybe you're thinking of the Tapper non-commercial hardware license, which is a different thing than the OHL. It's comparable, but that's what we released the HPSDR stuff under. And then after our first build, we converted it to OHL. But we're doing OHL right out of the gate here.
Well, that's what I wanted to know.
Yeah, we're
But
not doing the.
because it's really never been clear to me at all.
Okay. Well, it should be clear after you look at the schematic because it's on there and we don't mention the NCL at all. It's OHL is what we want.
I don't have those documents, so.
The schematic's up on our server.
And I
I
will
don't have any way
certainly,
to look at your schematics.
Well, there's PDFs on the Tangerine site if you wanted to look at them. So
Yeah.
they're there.
If they're PDFs, I can look at them.
Yeah.
and
yeah.
I will certainly be encouraging people to buy these things from Tapper. So,
Nuts not to, but
yeah.
But the thing about it is, once we sell out our first batch, if somebody can come up and make them for less, then let them do it. Because we don't really need to be in the business if we don't have to. We want to encourage the community to have the stuff.
Yeah. So, I mean, ideally we have this, I mean, you already have the first batch of magnetometers all made up.
I
So
do.
really, by the time this paper comes out, They're already going to be being sold.
You'll be able to buy them, right?
Yeah. So,
But
but
when is this paper going to be published? Or will it be?
I'd like to have it submitted by November to December, because I have to write an annual report for the NSF about the project, and it'd be really nice to be able to say that we have this manuscript submitted for this portion of the project. And then technically the grant's supposed to end this year, but I'm going to ask for a no-cost extension so that we can, you know, get everything together with the Tangerine.
Okay.
Does that sound, Human? Does that sound good to you?
Yep.
Yeah.
Well,
Because-
although you know, majority of this field cannot be filled by myself, because these are really engineering oriented. So
Yeah.
I mean,
But
definitely I can help you, you know, working on this template and latex and stuff,
Yeah.
as well as scientific aspect of it. But I don't think this paper specifically addresses like the scientific uses of that. But I can definitely work on that stuff if that's necessary.
Yeah, there's also a request for information regarding any comparable off-the-shelf or pre-existing systems of the same type.
Well, I already answered that in the table.
Okay.
If you scroll down the table, yeah, it is asking closest commercial analog. And I said, no, I guess, I mean, can you replace this with something else?
Well, I mean, the only analog that
would be Fluxgate or
would be probably, well, yeah, and specifically the SAM system, which is Fluxgate, but they have a kit which actually is also a variable device for temperature control. I think Dave Whidden bought one, but that's a Fluxgate. In terms of the magneto-inductive, I don't know of anything else in this category that is comparable.
Okay.
So,
well,
so if we stay with magneto-inductive, then no commercial analog is available, right?
So maybe you should make it a little bit more clear that you are just within the class of no magneto-inductive ground magnetometers are commercially available, or
right.
that there are no scientific grade ground magnetometers commercially available at this price point. Something that,
Sure.
because you certainly can go off and buy, you know, a commercial ground magnetometer that will replace this. You just need a lot of money.
Yeah.
Won't interface with the system easily.
Yeah.
Right.
But those devices aren't open source, are they?
Hard to say.
Not necessarily, but that's not what the question is. They're asking, what is the closest thing commercially available that is similar to this thing? So, you know, you'd probably pick the cheapest Fluxgate magnetometer that's commercially available and say, this is the closest thing. You know,
And it might be useful to explain that it's, you know, 5 times the price or 10 times the price or something.
right.
Like that. So it's not, yes, it's a commercial analog, but it's not really in the same price class. So, because what they're looking for is how unique are you, right?
Right.
right. Can people shop around to buy something similar?
And if it's, you know, if the other one, I don't know how much that Fluxgate one costs, but if it's $1,000, then, I mean, that's okay, but you got to know that you're going to pay a lot more for it.
Yeah, so I'll refine this. Actually, I'm working on it right now. Yeah, I can put this in more detail rather than no commercial.
So do we need to have I'm planning on writing a manual, very brief but to the point manual for the Tapper Pi Hat board.
Mm-hmm.
Do we need an analog to that for the other end on how to build? I mean, we need a step-by-step on how to build the in the ground portion, which we do not have. We have lots of reference material, but we don't really have a step-by-step.
Well,
and I'm willing to do that, but do we need that for this paper?
Well, I think, Hillman, you started essentially a repository of step-by-step type information for the ground magnetometer, did you not?
Are you asking me?
Yeah, I think because you already have some files that are aimed in that specific direction and as a how-to build.
How to build?
Well, the ground, specifically the ground, there was the PVC pipe, the mounting and so on and so forth.
That I do not have the detailed instruction. I thought you already had that the instruction, PVC.
To
There's
answer Scotty's question, maybe to address some of this, if we can include all of that, like build and instructions all into this one paper, that would be a really nice way to go, because we get it all out there all at once. It'd be peer reviewed. It would be, in a published journal, and then, people go ask for a PDF. There it is.
Yeah.
Right.
So you're saying this will be out in when do you need to submit this? Because I don't know how much time I have to get that done, because the first one is really important because we're selling a board. You have to get instructions on how to use it. But you also have to build the in the ground piece. Otherwise the in the house piece isn't worth anything. So you really have to have the whole thing.
Yeah. So, I mean, I'd like to get this out by November, but, it may end up getting delayed if we have to get some more of this.
Let me see what I can do, because my focus has really got to be on Tangerine. But
yeah, the most important thing for you is to get the Tangerine off the ground. There's nothing more important in the world from this project's perspective. I won't say about your life, because I know you've got a ton of stuff going on, but from this project's perspective, there's nothing more important in the world than you getting that Tangerine stuff done.
No, for how to build or how to assemble and construct the in-ground structure, that's pretty well set. The only thing we have to decide on is, are we going to say 1.5 inch, 2 inch, 2.5 inch PVC pipe, a few things like that, because there's no reason why we can't standardize on a specific diameter of pipe.
And I think I can answer that question right now is 1.5. Because
I'd go, right.
The board fits in there, and I've got a mounting system for the board to keep it vertical. The thing I don't really have well done is the grommet and assembly at the top, because I'd like to have it simplified. Yes, we know how to do it, but it requires drilling and or sanding and or some kind of machining, which I'd like to avoid if we could do it.
Scotty,
Yo.
I have designed a washer. Originally, I made it out of PVC, but since then I have created a 3D printed file that will print a washer like that.
Can you build me 250 of them?
Well, I don't know if I want to build 250, but I wouldn't mind releasing okay,
that's great. We should do that. But
G-code.
There's going to be the majority of people who are not going to have 3D printers that are not going to do it. So if we had a commercial equivalent, something you could buy, that would be great. Or if we had a way to do it without requiring sanding, a belt sander or a drill press or anything.
Right. So I built one out of a piece of PVC, and then just to try it, I designed one that was identical but made out of PLA. So,
and it both worked fine.
Yeah.
The mounting structure I used for the T fitting at the top, basically all the stuff was hand work with a step bit, hand drill, file. So it takes a little bit of time, but it was all handwork that anybody with a reasonably equipped home shop can do.
But what I'd like is a box of parts that you could just glue together.
Right.
Yeah.
And that's the ideal. Now we may never be able to do it, but
the only trouble is it'll be more expensive than going to the hardware store and buying it.
Maybe, depending on what you
buy.
I
mean, how much free labor can you get?
Well, I mean, if you could drill it with a hand drill, that's probably acceptable. If you don't need a drill press to get it centered or straight or anything. But what I'm thinking is that the like the normal cap that you buy has printing on the outside, which means you have to grind that off. Otherwise you don't get a good seal to the bulkhead.
Well,
Yep.
that's the advantage of this washer thing, is it fits inside the cap so that
Right.
you don't have to
But
grind
what I'm
it
thinking
off.
is if you can buy a furniture grade cap, and I don't mean you, I mean, if Tapper buys it and puts them in the kit, then
Yes,
it's already smooth. You don't have to do
Right.
anything to drill the hole. Now, I don't think our Tapper kit building guy wants to drill 500 or 250 holes in caps.
no,
But if you can do it with a standard size drill bit and a hand drill, I think that's acceptable. If you
I
need a
think we
drill
can do
press
that.
or a band saw or even a belt sander, no, I don't think so.
Yeah.
Well, you don't need a belt sander. You could just take a sheet of sandpaper, lay it on a flat board and do it by hand. I mean, there's
Yeah.
those raised letters aren't that high. And it's a little more work, yes, but everything can be done also with a step drill. A step drill makes an almost perfect hole. Then you take a half round bastard file and you enlarge it a bit into more of an oval shape that takes that
Right.
connector and locks it in place.
Yeah.
It takes you about 20 minutes to do it, but it's all possible with hand tools.
I agree.
And if you could get two parts I could just glue together, it would be much easier.
Yeah.
Sure.
In
But
looking,
I'm not saying that I would not do it that way. I'm saying that if I could do it the easy way, I will try. I may
Right.
not succeed, but in which
Well-
case we do it the grinding way, and that's fine.
Yeah.
You know,
You know,
it's also up to whoever builds it to say, okay, I can see a shortcut I can take. I'll try it. Go ahead, fine, have fun with it.
Yeah.
you know, there are build to order places for 3D print. So
Yes.
if you send a file to them, you know, folks can buy the 3D printed part from that web store. I think Steve Bible is kind of an expert in that, isn't he?
I haven't talked to him about it.
Yeah, I mean, Steve gave a DCC seminar on doing that kind of stuff probably 6-7 years ago. And
So if that's-
he may know where to find a place like that.
And if that's the case, and you can buy the thing for $1, then we just buy 250 of them and we put them in the kit.
Yeah.
And-
Right.
Yeah, so there may be some options.
Yeah.
I deliberately had a bunch of stuff fabricated to find out what it would cost by such a place, and it was not anything like $1.
Right. It was more like $10, right? Dave, it was more like $10 or more.
Well, no, it was
No?
several $100 by the time I got everything figured for.
Oh, for the whole batch.
Yeah, but it
Still,
wouldn't
that's
it wouldn't
like-
have scaled down much from there. I deliberately did it we've had all this discussion before. And I deliberately pursued this and spent some money on it to find out what was feasible in that regard. And I don't think anyone will find that a useful way to go. Including Tapper.
If we have to buy 250 of them and it's $750, then that's $3 a piece. So that would work for Tapper, not for the people buying them individually. And that was kind of what I was getting at, is that I'd like to buy everything that fits in a shipping box easily and put it in the shipping box. No 3-foot pieces of pipe, but anything we could buy retail, put it in there, and then buy the pieces that require the least amount of machining and sanding, and then go from there.
Yeah, if you can sell it as a kit, I mean, I think that would be ideal.
Yeah.
I just thought we'd put this whole discussion to bed a long time ago.
Well, we had it a long time ago. I don't think we ever got to sleep.
Yes.
Nathaniel, didn't the one you assembled for Hillman, your tech, didn't he do that cap as a 3D print?
He did the little holder for the magnetometer as a 3D print.
Okay, and
The
what
cap
did he-
that goes on top, I think he bought those parts from Home Depot or Lowe's and then put the little compass on top of there.
Okay, but how did he fit the connector to those to that top piece? I thought he 3D printed something for that too.
No, I thought he drilled a hole and then mounted the RJ45 connector to that hole.
Okay, which is basically the same thing I did here. Yeah,
Yeah.
all right.
Right.
Again, that's not a big
The
deal.
only 3D printed
Yeah.
part was the piece that actually held the magnetometer.
Okay,
Right, I think we have that solved because we used the piece of the foam covering of the insulators for pipes. And you could buy a 10-foot length for like $1.50, and we just cut it into a 3-inch piece and slit that in half, and that's the mount done. And it holds it almost exactly vertically because it crams into, it fits the ID of the pipe perfectly tight. So it slides up in there and stays there and doesn't wiggle around. It doesn't vibrate anything. So I think that is going to hold it as near vertical as the pieces that you would glue on, or
mhm.
okay, they were talking about some U channels that you would glue onto the inside of the pipe, but to try and get those all exactly vertical, it's problematic, I think. And I don't know, I know the azimuth you can adjust by rotating the pipe, and we can correct for that in software. If it's off vertical, how important is that to be exactly vertical? And can you correct for that in software?
Theoretically, yes, if you know how far it's off.
Okay, but of course we won't.
Right.
Yeah, I
The
think-
thing is that the mounting method you described actually holds it tightly to the walls, and it will be vertical.
Right.
Yeah.
It'll be
I
as
think
vertical
the
as the
only-
other way. So
Yeah.
I think that's, and it costs, literally it costs a nickel. So it's nothing.
Yeah.
I found that stuff too tight to fit. Those,
Well,
If
yeah,
you cut it in half,
yep,
and what diameter pipe?
1.5.
Okay,
well, actually what I did is I took the foam and I cut it in about a 60-40. Okay, and I don't remember which part I throw away, but the point is that you put the foam on the back side of the board. So what it does, it puts the parallel edges of the board tight against the curvature of the pipe, which
Right.
makes it vertical.
right.
Yes.
So, and so you don't put it all the way around. You put it on one side and it pushes it in.
Yeah, exactly. You're trying to force the board essentially parallel with the axis of the pipe.
Right. But it
Right,
does not
yes.
have to be, it doesn't have to be centered in the pipe, it just has to be vertical with the axis. Right. So it can be offset slightly from the center axis of the pipe, the center core of the pipe,
Right.
because the board is a little bit narrower than the 1.5-inch ID. So
That's
it's gonna
okay.
be a little bit over from the center.
Yep.
But at least since the two edges are parallel, it'll be parallel with the edges of the pipe then, the inner surface of the pipe.
Yeah, when I tried that here, it worked.
Yeah. So that's the cheapest way I found to do that. The thing, what I was really hoping that I could find would be an RJ45 barrel type connector, or a sealed type, double sealed,
Mhm.
actually these single sealed with NPT threads, because then I could thread it right into the T with some Teflon tape, done.
Right.
Nothing. So you just have to, there's no drilling, there's no grinding, there's nothing. It's just, a little RTV and a little wrench action, and that's all you need.
Mhm.
But I could never find one with NPT threads, so I think we're back to the cap and drill method.
Yeah.
And the other thing is too, the caps, if you try to put a nut on the inside of a 1.5-inch cap, it's very close. So you
Right.
end up having to grind off some of the corners of the nut.
Yep.
That makes it a little problematic to hold it in place. So maybe you want to go to a 1.5, 2T. So the side fitting is bigger. So you have enough room to put the cap in, and then your drill hole becomes a lot less critical. If you get your drill hole off center, then it's not going to even fit inside the pipe, inside the cap. Anyway, that's what I've got. Some PVC pipe here. I'm still looking around for the right adapter pieces, but that was my goal, was to get something really easy to just stick together.
Mhm.
And you can use RTV. I mean, I don't know whether you can buy a 1-ounce tube of RTV and throw it in the kit or not, but certainly anything you can buy at Home Depot and use right off the shelf is fair game.
Yeah, any decent hardware store will carry the RTV too.
Yeah. So, and you know, in a pinch, if you have to use a sanding block,
Mhm.
anyway, I think we beat that to death.
Yep.
But again, I think the assumption that anybody's going to really, that everybody's going to know how to do this is kind of presumptuous. I think there's a lot of people who are going to want simple instructions, and the sanding block and grinding it flat, that's a simple instruction. It might be a lot of work, but it's certainly not not beyond the capability of anyone. So hopefully we will have not for sale kits, but an example kit at DCC. So, and then you can be able to go online and order it. Does that fit in with your? Because I was a little late, sorry, but does that fit in with the scheme of software? If we have them available by the middle of September, is that going to give the people something to do with them?
Are you asking?
Yeah, I guess Nathaniel or Yeoman would be the one to ask.
Yes, I think so. Unfortunately, Bill's internet went out tonight, but I know he's been working on getting it to. So anyway, the short answer is yes. Yes, if you start selling it, we can start having people upload to the server and run things. Whether it goes to Dave Witten's server or to Bill Engelke's server, we can still talk about. But yes, they'll have things to do.
Okay.
Yeah, in terms of the soft current version of the run mag, Dave has put in a generalized equation for the gain function, so you can actually specify any cycle count you want. You could put 345 in if you want, and the gain will be automatically calculated to compensate for that. So so any problems we had before with potentially with the gain as opposed and citing a specific cycle count, you have more variability you can play with now. I mean, we can stay with the standard cycle counts we were talking about and standard averages and stuff, but it's easier to use and it's reliable and it works. I've been running a 600 cycle count at I think an average of 24 for the last 2 weeks, and it works using the latest version of the software, which includes the timing stuff that Bill put in, and it seems to be quite accurate on 1 second boundaries.
So does Bill's software handle that too, the variable count?
Bill's software is just going to be for collecting uploads. So it's really the systems are really going to be using Dave Witten's software to actually drive the magnetometer.
That'll be run on the Raspberry Pi then.
Yes.
Okay.
Yes.
Okay, I got it.
Yes.
Which is the other thing, we're going to specify the Raspberry Pi as the engine for it, and we're not going to talk about any other possibilities like an Odroid or whatever.
Okay.
That's the other piece I wanted to bring up is what are we going to talk about for the local host? Raspberry Pi, if so, Raspberry Pi 3 or Raspberry Pi 4, or either one of the two. Both of them work. I have a 3 and a 4 working on both.
Can you use the same software image for both or not?
Yeah, I've been doing that.
If we have
I don't
it,
know, Dave? Dave's still here? No.
No, Dave Witten left.
No.
yeah, if we have it tested for the Raspberry Pi and 3 and 4, I don't see why you wouldn't discuss both of them.
Especially if you could just plug either one in and there's no changes. Yeah.
But I wouldn't, I mean, and we could say, other systems may work, but these are, not supported or have not been tested, or it's left to the user's own.
That's right. It gives us an out so we don't have to go down the rabbit hole of making every variant work.
But the Raspberry Pis 3s and 4s are very common. I think supporting that is more than sufficient.
Good.
Yep, agreed.
Yeah, we can't make this so complicated. We can't do it.
Right.
Yeah. And pick the common denominator, and you're going to get 90% of the people who are going to just go buy a 3 or a 4, and they're going to plug it together, and they're going to load Dave's software on it, and then we hope that it works. So I'm thinking maybe an addendum in the user's manual for the software, the installation on the Pi and that kind of thing. Because this my manual is going to focus on what do the jumpers and switches do, how do you plug the thing together, and how do you plug it onto your Pi, and after you got it all wired, then what? Then you got to go do the software portion, which is kind of like an addendum thing. But that'll be only one method if we pick only one single board computer, right? So sounds good.
I'm sorry, but I need to go. So I'm
Yeah,
gonna
me
say
too.
73.
73, Dave.
See you, Dave.
Yep.
I think I need to cut out as well. No.
Thank you.
73.
Nathaniel, I
very
have
much,
one
Bill.
thing to mention.
Yes.
I was talking with Alex Chartier about sounders,
Yes.
and he's planning to use a terminated folded dipole for his low power sounder.
Okay, good. Oh yeah, I did have a email conversation with Bob McGuire over the past week, and he did confirm that we could use some smaller antennas, and we can even just focus on the upper portions of the band for the initial testing that we're going to do. So
Yeah,
I don't
that's true, too.
necessarily need to. I don't need to dominate my entire backyard.
Right. Because
And
even
not
a
to
90,
mention,
90-foot one will respond down to 2. It just drops off quickly.
yeah, not to mention the fact that there's no way we could build the thing that was described there on the budget.
Yeah, that was.
Yeah, that was just not going to work.
Yeah, that was an interesting idea.
Yeah, but I have let's see. So I know Gerard, who's the student that's going to be working on that project. He'll be going to Tapper DCC, and I imagine Bob McGuire, I imagine will be there too. So hopefully we'll all get to meet in person and chat a little bit.
Yeah, Bob won't be there on Sunday, I think, is what I heard, because he's going to a concert.
Oh, okay.
Tennessee. So
Okay.
but I think he's planning on being there in person on Saturday.
Great.
Saturday.
That's good.
And has John Hayes contacted you yet about the Sunday seminar?
No.
Okay. I'm going to put you in touch with him because he's going to be the moderator for Sunday.
Okay.
He's agreed to do that. And we have our speaker for Saturday night. It's going to be Rosie from ARDC.
Oh, great.
The banquet.
Uh-huh.
So things are progressing along.
Good.
And I should have mentioned this earlier. 1 week from today is the deadline for the 22nd, I think.
The
Yes.
hotel.
The end of Sunday, I think, was the deadline for hotel reservations.
I have the hotels for myself and all of my students.
All right, good.
And I have my flight and I have my registration paid.
All right,
So
you're all set.
Jonathan, did you book you booked your flight and hotels and everything, right?
Hello, Jonathan.
Yes, my flight and my hotel is booked. I did not book the. I did not purchase the registration yet, but yeah, my flight and my hotel are booked.
Because the hotel is very important because there's regular rates like 209. It's more than double what our rate is. So
yeah, yep. I used the link and I got the $99 rate per night.
Yep.
And I also put in my Hilton Honors code too.
Mary Lou, are you coming?
Yes, I'd like to come, but I have done nothing.
Okay. Do you need
Talk later.
Okay, great.
So, quick question for Nathaniel. Well, I was gonna ask for Dave Witten here, but he left. Data repository and then plotting toolkit.
Mm-hmm.
Are we planning to merge HF and magnetometer together, or?
I would like to. I can go over that with you now if you'd like.
Yeah, I mean, basically, I was thinking to have someone in NJIT to work on that data archive in collaboration with Dave Witten. But if you plan to, I think that makes much better sense anyways, because that's our strength, right?
Yeah.
To show HF communication, ionospheric disturbance with the contextual data, which comes from magnetometer. That makes much better sense. So
Yes.
yeah, having all of this toolkit in one place would make much better sense.
Yeah, I think it's really the thing to do. So here's what I've started so far. So I've created a repository. Sure, I'll put a link to this in the chat here. To find the chat. I have to set this to everyone in meeting. There you go. Okay, so there's a link to the repository. So I have it called hamsci_PSWS, and it's under my account right now, but we can move it to the hamsci account. And I've been doing these scripts. So right now I have these example notebooks. So if we start with the single station time series plot, you can click that notebook. And this has all been run already, but it lets you, this is all geared for the grape. So you do your imports up here and you can import hamsci_PSWS. And we have some code that actually Christina came up with this part to come up with a grape inventory that will give you a list of all the nodes and the people's names and where they're located. And so it's a table of station information. And then from there, it doesn't show, there's a code there that will plot a map of all of it. And then when you load the data in, the grape data looks like this by default. So it has the raw data for the Doppler shift looks like this. The voltage data looks like that. It's rather noisy. So I have a digital filter in there where this is a low pass filter that I have it set so you can just say, how do I do this? Okay, right here. So I tell it what node to load. I tell it the start time, the end time, what frequency, and then I tell it and I tell it to load the data, and then I tell it to process the data. And I currently have a standard processing scheme where it computes the solar local time, it applies the filter, converts the power levels to dB. And so then you can just plot the raw data here. You can tell it to plot the raw data with the filtered data on top. You can, and you can do it in either UTC or solar time. So as I said, this is all geared toward the grape right now, but the way we have it structured is if you look in this hamsci PSWS directory, there are different modules. So there's a grape 1 module. I would imagine having another module that would be for the magnetometer and another module that would be for the VLF.
Okay.
And if we do it, ultimately, it'd be nice for it all to have a similar plotting interface. And I know on the grape project, we don't have the people, we don't have the money yet, but starting next summer, I'll have money to hire a software engineering student, master's student from Scranton that could work on this. And, and they could actually apply like real software engineering principles to this. And we'd have that person for 2 years that could work on this. And then in the meantime, people like you, me, Diego, Christina, Jonathan, other volunteers, we can work on building this up. But if you start if I sit down with you and Diego, I can show you kind of what I'm doing here in this particular module. And then you could probably write a separate module just for the magnetometer. And that way you could develop the magnetometer one independently from the grape one. And then we try to keep the interfaces as similar as possible. And then when we kind of have that working, then we can try to unify it a little bit better.
Yep. So
And then ultimately, like, if you look here at this multi-station one, I have the code so it'll automatically load multiple grapes, and it will also automatically plot GOES data on top. So, I'd want a module so you could have it, plot your GOES data, plot your Omni, SIMH, or AE, or your solar wind or IMF data on top in one panel, have another panel that does this, and another panel that does magnetometer, another panel that does
yeah. So one of my students has already built like this kind of like Python environment for the processing of magnetometer data on Colab.
Okay, great.
So then I think the rest of the job is a matter of just transplanting whatever we have to your system and work on some cosmetics aspect. Yep.
I agree with that.
Yep. I think we're there. It's just that we're still, I think students have a hard time understanding the different formats of magnetometer data that I think that's because he was looking at the initial data set that, when we were scrambling each other, the data formats are a little bit different. So he was trying to unify the format so that we can process things from one end. But now I think things are settled. So we are ready to move.
Yeah, it'd be great if he could work on integrating some of these things. I'm asking Christina. So Christina is actually the main owner of this. I'm asking her to move this over to the HamSci organization. So it'd be github.com/hamsci/hamsci-psws. Then once we do that, then everyone can like submit pull requests against that main HamSci repository.
Okay.
I think, one thing that I think this is going to be a really good way to start. I think the hard part is going to be like getting the whole interface to be uniform between everything. I think that will take someone with a lot of dedicated time, and that's where I'm hoping, you could turn that into a Master's of Science and Software Engineering project for the person at Scranton next year. That's one possibility. But if we can get as much of it, useful as we can with the people we have, that would be really good.
Okay. Yeah. Yeah, and the important thing is, as some observing points using magnetometers will not really lead to any scientific new findings. New findings right now. I mean, it's been done before a lot. So what we are really pursuing is to have a large, extensive array of magnetometers so that we can see this ionospheric convection patterns, disturbances in more detail with better spatial resolution.
Yeah.
Which still lacks these days. So the more the better, the more the merrier kind of approach is critical here.
Yeah, I agree.
Yeah.
Building a whole toolkit like this from the ground up is a lot of work. Does it make sense for us to go this route, or does it make sense to try to join up with some other project?
I have mixed feeling about this because one thing is we have our own unique and strengths, unique strength. So we don't want that to be compromised.
Right.
But the other thing is, yeah, I realize that there are many other citizen science projects where the same type of magnetometers are used, PNI sensors. I know UNH Alaska, they use the same PNI sensors and then similar kind of configurations and stuff. And so
do they have a data visualization toolkit like this?
some sense, yeah, I think so. I don't know how much it is developed, but the approach, as I said, the approach is a little bit different because they are working mostly with like local students. So I think they are more concerned about the data quality assurance. Who knows how they are installed, whatever. Now even Jesper at APL, who runs SuperMag, is also running a citizen science project that utilizes the same sensor, PNI sensor.
Yeah.
With the local students.
Yeah.
So maybe we can have our data set sort of integrated with their data repository.
Yeah.
I mean, if our data sets are provided for their SuperMag as part of SuperMag effort, then that'll be great. I mean,
yeah,
be part of a really well-known, highly respected SuperMag data repository. Plus, I think what Jesper told me is that he will make sure that all the data qualities are by their standard. So that way, we can not only just provide our own data set, but also we can also rely on their data quality schemes as well.
Yeah.
But again, I really like to stress that we don't want that our uniqueness and strengths to be compromised.
No, but maybe what I have up on the screen, maybe this is where more of what I'm thinking of. You know, SPDOS, of course, right? Like, it would make a lot more sense. Like SPDOS, which is apparently, they have PySPDOS, so it's already in Python. They already have, I'd imagine they already have ground magnetometer tools in here, right? And we could probably put grape reading tools in here as well. And then you already have access to all of the other, the Discover and the GOES and the Omni, and maybe we should be using this.
Yeah.
Because I mean, from the magnetometer standpoint, you don't really I would think they have all the ground magnetometer stuff already worked out there.
Right.
Certainly the grape stuff would be different, and that would require more development.
Right. The magnetometer stuff should be pretty straightforward. I mean, it's the magnetometer data itself is not that unique.
No.
So it can be integrated into other systems very easily. The one thing that I really like to do, with you guys, is to show our strength by integrating our magnetometer data with grape data to show the contextual space weather monitoring capability.
Yeah.
Yeah.
But I mean, I'm looking at this, and this really has everything we already want in it. It's just, and they already have a way of doing it.
Yeah, looks nice.
Right.
Yeah, because for us, and like Siginenko's in here, look at that, Siginenko, the solar wind parameters. for us to go and reinvent all of this is, if this already exists, is kind of ridiculous.
Right. You're right.
So, I mean, I guess I'm not sure who we have to contact about this, but I don't know if it's Vasilis or who's actually in charge of this, but I'm sure we can find that out. But it probably makes sense to at least explore this possibility.
Yeah, that sounds like a good idea. I haven't really thought about this, but I guess. And do you know how active this SpeedUs is? I know this has been
Well, here you can
found.
see the last commit was 6 days ago, and there's 1,913 commits. So you can just look at this, and it's easy to see the commit history. So it looks reasonably active. And I think they actually, you know, I think they had funding to do this too. The other project, another project, there's a few projects that are similar. You know, there's PyDarn, which is the SuperDarn one, but that's a little more specific to SuperDarn. And I'm actually involved in the PyDarn one, so I don't think that one would make as much sense as SpeedOS would, because SpeedOS is more like time series data. And I do know they have, I know they have some ground magnetometer.
They should have some kind of spectral analysis there too.
Yeah, they should. Oh, good. They do have notebooks. Here's their flux gate magnetometer example notebook. That doesn't show a whole lot. Ground magnetometer data. They're not showing any plots here. Okay, well, we'll have to think about this a bit more. I think we should have some more discussions about the analysis toolkit, because whichever way we go, it's going to be a lot of work. I think we need to have something. We have to have, you know, some way that we go about providing some tools for this. And certainly if we are able to piggyback on something that is established, it does have the advantage of being established already. And like, you know, here you've got these Themis All Sky Imager keyograms, you know, that if we use this system, it would automatically be available. Like all of these tools would automatically be available to us. And similarly, all of our data would automatically be available to all the SpeedOS users. And that's kind of very powerful.
Yeah, of course. Yes.
And there's no way. I mean, I tried, you know, I've written some things with loaders for loading the Omni data and the GOES data. And, you know, there's no way that just one of us can go and do all of that. Especially when it already exists.
Right.
What's that, Mary Lou?
Yeah, use it if it already exists.
Yeah. Well, my computer's at 6%, so I think it's telling me it's time to go to bed. But thank you, everybody.
All right.
Good
See you
night.
guys. Yeah, have a good night.
Bye,
Thank you.
Hammond. Bye, Mary Lou.
Bye-bye.
Jonathan, David.